Good morning. How's everybody?
Good, how are you?
I'm good. Thanks for asking. I'm feeling better today, so glad to be here. Sorry about yesterday. I hope that recording went okay. If you didn't get a chance to listen to it, it's still there. It's not going to go away. It was some sig fig stuff, some unit conversion stuff. We'll do some more of that today and just make sure everybody has that down, okay? So the attendance sheet is going around the room. Make sure you sign in. Homework 1 is posted. Most weeks, homework, the normal pattern will be due by Saturday night. I would recommend starting earlier than that, okay? Pretty much all that's in homework 1 you should be able to do, or should be able to do most of it, so you can get started right away. Quiz number 1 is due Sunday. Don't forget at least my philosophy on the quizzes, there's 3 versions that are posted. So when you look in Achieve, you'll see quiz number 1A, quiz number 1B, quiz 1C, okay? And the idea is to test yourself. Take it like a test. No notes, no books, no help, and just see how you do on the first one. And that's testing yourself to see if you really did learn this material, okay? So if you don't do as well as you would like, you have 2 more opportunities to do well. So give yourself time, okay? From past semesters, I have lots of students who take that quiz philosophy seriously and do at least 2 or 3 of the quizzes depending on what they need. I have other students that wait till 11 o'clock Sunday night and take it one time. Okay, and that's kind of not the idea. So take advantage of that. My office hours are after class, Monday through Thursday. So come see me if you need some help or just have some general questions. And we will do a seating chart in here tomorrow, so find your spot. Okay, and then that's where I would like you to sit for the remainder of the semester. Has everybody pretty much kind of found where they like to be in the classroom? Usually that's the case. So anyway, so that will help out. And let's say hello to Chemistry Cat before we get started. He's here somewhere. There he is. So it's probably what a lot of you think about my chemistry jokes. Once I told a chemistry joke, there was no reaction. Okay, can't win them all. So let me just double check that I'm recording here. Yep. Okay. All right. Any questions on what was covered yesterday? Yes.
I was just wondering, is digits synonymous with figures?
Yes.
Okay.
I typically say significant figures, but significant digits, it's the same thing.
Because I'm like, why don't we say sig digs instead of sig figs? So I would.
Yeah, it just depends on the book you look at. A lot of books that I've used over the years call it significant figures, so then we just call them sig figs.
Okay.
And then this book calls them digits. Sig digs? I don't know, but anyway, but yeah, same thing. Other questions? Yes?
Not related to this, for the quiz, and I apologize if you answer this, do you take the highest score or the last score?
I take the highest score. So, if you score, say, a 90% on the first one and you just want to give it another try and you do worse, it can happen. You do worse on the second try and you're like, I'll just take the first one, that's fine. Okay, so there's no penalty for taking, the quiz another time, even if you just want more practice. Sometimes it's good just to go, if you have time, do a little more practice with the material. The other thing that I'm going to post, and it's not going to be for credit, but you'll see it show up. There's these, what they call adaptive quizzes, okay? And I haven't really figured out how to use those yet. I used them a little bit last semester in a course I taught, which was Gen Chem 2, but I didn't quite figure it out. And so I'm just going to let you kind of practice with those. And so what it does is if you miss a question, it will give you more questions like that. And so it'll be a good review thing if you have more time. All right, other questions? Yes?
So the quiz is 15 questions you said before, or?
Well, there's no set amount of questions. Typically, it depends on how long the problems are in a given week. A lot of times homework might be up to generally, and this is 20 questions, quizzes 12 to 15. This week they're longer just because a lot of the questions are punch these two numbers in your calculator and report the answer. That's going to take you hopefully only like 10 or 15 seconds. Okay? So this week they're longer, but generally they're probably in that 15, maybe 20 range for the homework. But it depends. Some problems during a week, they might be really long problems, so there'll be fewer.
Awesome, sounds good.
Okay? Yes?
So I'm in the grace period for Achieve, and I'm just wondering, like, can I pay for it now, or do I have to wait until it notifies me when it's released, or how it's gonna ask?
I don't know, but I would assume you can pay for it when you want. But if you get to September 6th, I believe, do you know the answer?
Whenever. You just have to click on the access thing and then
Because it's like extend access, so I'm like, okay, well, I'll click this link, and it literally doesn't, it's not live, like, it doesn't lead me anywhere, so I'm just gonna call it.
Yeah. As far as I know, September 6th is the date by which you need to pay. So if you don't pay by then, it certainly will let you know. All right. Good questions. Any other questions while we're just hanging out? Yes?
I got stuck on a problem on the homework. Is there any way we can find questions like that where we can practice?
Oh, additional questions like that one? Well, you'll certainly you might see more questions like it in the quiz. I am going to post this adaptive quiz, and that will be for, I don't think there's an adaptive quiz for Chapter 1 material, but there is for Chapter 2, so I don't know which.
It was subtraction on top and then division and finding out the sig figs.
Okay. Yeah, certainly within the adaptive quiz, you'll see more of those. So I would look through there and do some of the problems in there. And then it'll try to, if you miss ones, then it'll try to give you more of that type of problem. So that might be a good way to get at it. I don't know, I'll have to look in the book. I'm assuming there's end of chapter problems. So if you look in the text itself, the e-text, there's example problems throughout, one. So you might want to look at the example problems in that section of the chapter, and there might be additional problems you can do at the end of the chapter, but just actually from the book itself. Okay? All right. Anything else? Don't want to rush us. Good? Okay. All right. This is where oops, that's exciting. All right, this is where the lecture from yesterday left off. And this is important because you'll see it. So typically for volume, when we do volume measurements in chemistry, we will use the metric system. We won't use the English system of ounces and cups and pints and quarts and things like that. So become familiar with centimeters cubed, milliliters. Again, that's a really cool thing about the metric system, that we can take a cube 1 centimeter on an edge, and that's a fluid volume of 1 milliliter. Okay, so certainly make sure you know that 1 milliliter is 1 centimeter cubed. And then if we want to scale that up, and I do not have a pen. Let's see, let's choose a different color. Okay, so if we want to scale that up, you probably know that 1 liter is 1,000 milliliters. Okay, and make sure you look at that conversion. Oh, let's actually write it this way. Okay, so when we write that, make sure you realize that that is an equality. So on the liter side, we have the number 1. And on the other side, on the right-hand side of the equation, we have 1,000 times milli. And what does milli mean? What number is that? 1,000th, or let's use scientific notation. 10 to the negative third. Okay, so make sure you know your metric prefixes. Okay, So now we have 10 to the third, which is 1,000, 10 to the positive third, times 10 to the negative third, and that indeed equals 1. Okay, so if we were to multiply 1,000, 10 to the third times 10 to the negative third, that would equal 1, so our two sides of the equation are equal. Okay, so 1 liter, 1,000 milliliters, you know that, and we know a milliliter is a centimeter cubed. And so we will use this conversion factor at times, 1 liter, 1,000 milliliters, or 1,000 centimeters cubed. Okay. In the lecture yesterday, I did talk very briefly about decimeters cubed. We don't need to use that. You will see that in the book. We'll just deal with milliliters, liters, centimeters cubed. So I think it's easier that way. All right, any questions on that? Okay. So let's skip this one. This is just in the notes. How many decimeters cubed? We don't need to do decimeters cubed. So let's skip to this next one. Okay. Oh, actually, let me write it down here because it's going to come up on its own. So if we were to write a conversion between meters and centimeters, what number do I need to put in front of centimeters to make that an equality? Okay, it's 100, right? So centi, and again, make sure you can write out these conversions. Centi is 1/100th, or 0.01, or we like to use scientific notation in this course, 10 to the negative second. So to equal to 1, we're going to need to multiply by 100. Okay, so 1 meter is 100 centimeters. Okay, so make sure you can do that. Now we're going to start dealing with cubic units. So if we want to find out 1 meter cubed, okay, so we're going to take 1 meter, so we're going to cube that whole thing. So we need to do the same thing to the centimeter side of the equation to get to cubic centimeters. Now, on the left-hand side, we have 1 cubed, which is just 1. But on the right-hand side, we have 100 cubed, along with the unit, okay? So we could also write this, and let's see if I can write it somewhere where it's not going to get covered up. And let me put meters cubed on the other side. So 100 centimeters cubed is 100 times 100 times 100 centimeters each. Okay, so break out your calculators and do this calculation for me. See if I can put this up on the screen. It will come on. All right, so doing that calculation, punch in 100. You probably know how to do this, but we do have this caret key, and we're going to cube that. Okay, and I have my calculator set to scientific notation, which you might want to do for yours as well. And we end up with 1 times 10 to the 6th. All right, so let's get rid of that. Okay, so if you want to write that in decimal notation, that would be a million. But we will typically use scientific notation, so that is equal to 1 times 10 to the 6th centimeters cubed. Okay, so the key point to make there is anytime you are, whether you're squaring your unit or cubing the unit in this case, don't forget to do the same mathematical operation to that number. Okay, it's easy to forget sometimes that, oh yeah, we have 100 centimeters cubed, and we just cube the unit and we move on. Don't forget that you cubed the number. Yes? Yeah, this is exact. Like there's exactly 100 centimeters in a meter. So we have as many sig figs as we need. I only wrote it to 2 just because it's an exact number. It doesn't matter. But that's a good point. So any of the metric conversions are exact. And there's a few other ones. The one between inches and centimeters. But so we'll do some calculations in a minute while we'll talk more about sig figs. All right, any questions on cubic units? Yes?
Why do we still have it cubed at the end?
Cubed where?
Like the centimeters cubed after it's already a million.
Because we're still talking cubic centimeters. So what we're saying is if we had a cube that was a meter on an edge, okay, so in your mind, so a meter, a little longer than a yard, so like 39 inches, right? So take a cube that's a meter on each edge, and that would hold 1,000,000 little cubes that are a centimeter on an edge. Okay, so fill up that meter cubed box, and it would actually take 1,000,000 cubes that were much, much smaller. Okay? Other questions? Yes?
Just making sure I'm using like my calculator right.
Okay.
But when you typed in your calculator, you did like the caret thing.
Uh-huh.
The third.
Yes.
Do you also do E?
Well, I did not because my calculator here, let me go back. My calculator was already set to scientific notation, so let me clear this. So I just put 100 and then caret cubed, so that's 100 cubed. And then because I already have mine preset to scientific notation, it's just gonna come out in scientific notation when I hit the equal sign. So 1 times 10 to the 6th, okay? If you have it set to floating point, it will come out to 1,000,000. So make sure you know how to switch. So if on this calculator, if I hit, well, I can do a couple of things. I can go to this science engineering second function at the top, and I can switch to floating point. And so it might be hard to see, you can see that. So there's 1,000,000. I can switch back to scientific, okay? There's even a fix down here at the very bottom. You will see this second function fix. So you could hit that. Oh, that sets the digits, never mind. It doesn't actually switch us back to decimal. Okay, does that answer your question? Okay. All right, let's practice a conversion, and then we'll talk about sig figs as well. So IV fluid at the rate of 95 centimeters cubed per hour. How many liters of this fluid does the patient receive per day? Okay, so this is where we're starting. Okay, so 95 centimeters cubed per 1 hour. Okay, so per hour, per 1 hour. And we want to get to liters per day. Okay, So we have to do two conversions, right? We have to convert the numerator. We've got to get from centimeters cubed to liters. And we have to get from hours to day. All right. So how many centimeters cubed in a liter? 1,000. So 1,000 milliliters in a liter or 1,000 centimeters cubed is equal to 1 liter. And then the other conversion factor we need, there are 24 hours in one day. Some days I wish I had more, some days I wish I had less. Just depends on the day. Okay, so from these equalities, you need to write two conversion factors. You need to decide, do you need to put centimeters cubed in the numerator and liters in the denominator, or the opposite of that to get to the unit that you want, okay? So we want centimeters cubed to go away. We want to end up with liters. So come up with a conversion factor for that. And then we want hours to go away, and we want to end up with days. Make sure you notice that's in the denominator. So you have to arrange that the correct way. So take a minute. Feel free to talk to others around you. Ask me questions, and see if you can complete this. Yes?
Are we eventually gonna have to do like let's say 95 was in centimeters instead of centimeters cubed, and then we still had like a liter, you know what I mean? Like, are we gonna have to do that?
Well, so if we just had centimeters, that wouldn't be a volume unit. That'd just be a length. So and if we're dealing with volume, it would either be a cubic volume, like centimeters cubed or meters cubed or something, or to be a fluid volume unit of some sort, okay? Other questions? Got it? That looks good. How's it going? Yep, that looks right. Yeah. I'm sorry?
So if it comes out to 10 to 0.
Yeah, then you would just be 2.2 it, yep. Okay, as I walked around the room, it looks like most of you are getting this. One thing that you might want to do when you set this up, there's different ways to solve problems. I always, of course, like to write on the left what I'm starting with, okay, the 90 centimeters cubed per hour, and then write the units that I want to end up with on the other side of the equal sign, so that just kind of gives me a guide to where I want to get to. And then sometimes I will even just write the units in before I write in the numbers, because I know I want to end up with the liters, and I know I want centimeters cubed to cancel, okay? And then I want to do the same thing for days and hours. I want to end up with days down in the denominator, and I want hours to cancel out. So hour divided by hour is just 1, cancels out. Okay, and then I can just write my numbers in from my known conversions. Now make sure you realize I might give you on the equation sheet on the exam, I might put, if I'm nice, 1 milliliter is equal to 1 centimeter cubed. Okay, but you should know that. You should know that conversion. That's something that you need to know. You should certainly know there are 24 hours in a day. So these typically would not be given. Okay? But then if we do know those, we just write in the numbers that we have. And then the same thing, 24 hours in 1 day. All right, and then when we use our calculator, I tend to just go, yes.
So I'm kind of confused about how, so if 1,000 centimeters equals 1 meter and a liter equals basically a meter cubed, how does it, if you look at a liter, it's tiny.
Well, so a liter is not a meter cubed. A liter actually turns out to be a decimeter cube, but we don't need to mess with decimeters. We just don't need that.
Okay, that makes sense.
Okay, so keep in mind, here's our two conversions. 1 liter is 1,000 milliliters. Okay, you okay with that? And then we know 1 milliliter is 1 centimeter cubed. So we can interchange milliliter and centimeter cubed as much as we want. They're the same volume. And again, that's such a cool thing about the metric system. You might not appreciate it yet, but we just don't have that equivalent in the English system. Okay? So 1 liter is 1,000 milliliters, or equivalently 1 liter is 1,000 centimeters cubed. Okay? All right. So this is multiplying and dividing. Order of operations doesn't matter for that. Okay, so multiplication, division have the same order of operations. So I typically just start on the left, and I'll put 95, and then anything in the denominator I divide by, anything in the numerator you multiply by, and you can just do those in order from left to right. So we are going to take 95, we're going to divide by 1,000, and then we're going to multiply by 24, and we get 2.28. Do I need anything else? Unit. Liters per day. Okay. Okay, and it's going to be kind of hard. It's always a good idea to kind of look at your answer and at least see if it kind of makes sense. So if you start thinking, okay, 95 milliliters, okay, about 1/10 of a liter per hour. Okay, 100 milliliters is 1/10 of a liter, about 1/10 of a liter per hour. You know, by the end of a day, 2.28 liters. Okay, you know, we know it's going to be a larger volume over the course of the day. That seems about right. Okay. Now you'll notice if you have your calculator in scientific notation, it's going to give you times 10 to the 0. Okay, and so 10 to the 0th power is just 1. So that's just 2.28. All right, any questions on this conversion? No questions? We're all good? All right, make sure you know these metric volume, these cubic volumes. The milliliter is a centimeter cubed, 1,000 centimeters cubed per liter. You will see that quite a bit. Oh, I'm gonna have to just skip through here because I wrote over top of everything. Oh, come on. All right. All right, we'll do some short conversions again. Oh, we didn't talk about sig figs. This was an easy one, but let's back up. Let's go back to sig figs and all my mess here. So, sorry about that. Let me erase some stuff that's on here just so we can at least see the same stuff. Okay, so focus on this line here. So we start with 95.0. How many sig figs is that? Or significant digits, if we want to use digits and not figs. Okay, it is 3. So trailing zeros, so that 0 is a trailing 0. It's significant if there's a decimal point. So that's 3. What about 1,000 centimeters cubed in a liter? How many sig figs there? Infinite. That's exact. There's exactly 1,000 milliliters in a liter, or 1,000 centimeters cubed. How about the next one, 24 hours in a day? Yeah, that's exact as well by definition, okay? So the only thing that we have to worry about the sig figs is the first number. There are 3, 95.0, so we're going to carry 3 in our answer. So multiplication and division, the least precise measurement, the fewest number of significant digits, that's what you carry in your answer. Okay, not too bad. All right, so density is important for chemistry, also for other sciences as well, and we'll also tie that into some conversions in just a minute. You probably know the definition of density, mass per volume. Okay, so the typical, if you want to start talking about units that we will use for liquids and solids, typical unit would be grams per milliliter, okay, mass per volume, or equivalently grams per centimeter cubed, okay, because a milliliter and a centimeter cubed are the same. If we talk about gases, they are much less dense than liquids and solids. So for a gas, typical units for density, grams per liter. Okay, and again, a liter is a decimeter cubed. I'm not going to make you memorize that. So you might see it written like that. But gases are much less dense, so we're going to talk about the mass of a gas over a much larger volume. Okay, typically we will abbreviate it M for mass, V for volume. No big deal. And so this example from your book's talking about the density of this prosthetic limb. Obviously, you can use materials that have high strength to weight ratio. That would be a good thing here. Same thing for a kayak. High strength to weight, which gets to density. All right, so just do this calculation very quickly. This is calculating density straight up, and then we'll set up the next one as a conversion. And let me actually write down at the bottom so I don't get in the way of. Okay, now I will put that equation on the equation sheet. It's not like it's a hard equation. Obviously, you will probably know that, but just in case you forget on an exam, you don't want to miss a problem like this. So do this calculation very quickly and then look at your answer and then ask yourself, does my answer make sense based on knowing the density of water? Okay, knowing the density of water, does your answer make sense? Okay, so this is just straight up plug in your numbers. No big deal. You're given the mass, divide by the volume. And you should get a density of 1.09 grams per milliliter. Okay? Yeah, so we have 4 sig figs in our mass. We have 3 in our volume. So we're going to carry the fewest in our answer. Again, multiplication, division. Whichever number has the fewest, that's what we report in our answer. So since 10.4, has 3 sig figs. We're going to carry 3 in our answer. Okay? Next question. Does your answer make sense? So knowing the density of water, pure water, will help. What is the density of pure water, roughly? Yeah, 1 gram per milliliter. So know that. That's a good starting point. So this is salt water. So we have salt dissolved in the water. Does it make sense that the density goes up a little bit? Yes. Okay. And I've never been a great swimmer. Kind of embarrassing. My wife is an amazing swimmer. She qualified for the Olympic trials twice, way back when. So I go swim with her, and she's like 3 times faster than I am, which I guess I got to suck it up, you know. But I've always had a really tough time floating. Like I sink like a stone, okay? But when I get in the ocean, I do a little bit better because the water's more dense, so I can actually almost kind of float, but not really. Okay. All right, any questions on straight up density calculation? All right, now, there's a couple of ways to solve this one, okay? And your book, the book that we're using, is gonna set it up and rearrange the density equation. So I will show you that one. But I wanna show you how to set this up as a unit conversion, okay? So hang with me on this. So we have the density of antifreeze. Note that again, it's a little bit more than 1 gram per milliliter. So antifreeze typically is about a 50-50 mix of water. And then that, whether, you know, if it's more animal friendly, it'll be propylene glycol rather than ethylene glycol. But you mix those two together to raise the boiling point of the water. So density a little bit more than 1 gram per milliliter. You measure out 600 grams, what volume will it occupy? Okay, so I'm gonna do a unit conversion, and I just want you to see this because I think this is good since we're talking about conversions. We're starting with 600 grams of the solution. We don't have to write solution here. Now, typically when I write solution, I abbreviate, and so SOLN is solution. Hang with me, it's all right. And we want to get to what? What do we want? What unit do we want to get to? Yeah, we want to get to volume. So since we're already in milliliters, or since the density is in grams per milliliter, let's get to milliliters. All right, so now let's take density and arrange that so that grams cancel, and we end up with volume. Is that pretty easy? Right, we can write this as 1.06 grams per 1 milliliter. Okay, so when it just has ml in the denominator, that's per 1 milliliter. So how do I need to, that in effect conversion factor, that's the density, can I use it just as I have it up at the very top of the screen? No, what do I need to do with that? Flip it. So I'm gonna write it as 1 milliliter is 1.06 grams. Grams in the numerator, grams in the denominator, grams divided by grams, just 1, and we end up with milliliters. So 600 divided by 1.06, and we end up with, so how many significant figures should we have here? 3. So 1.06, we kind of, every calculation seems to be 3. That's not the case, but in at least the ones we've been doing today. So 1.06 has 3, we carry 3 in our answer. We could write this in decimal notation, 566, or if you would like 5.66 times 10 to the second milliliters. Okay? Yes? Well, yeah, so, it's kind of unfortunate because, there's natural log, which is log base E, which is a different, Euler's constant, is a different thing. But on most calculators, you hit, the EE key to input scientific notation. So I don't know if that's your question.
Do I have to be in the scientific, like?
Well, if you want it to end up as 10 to the, like mine, I have it in scientific notation. So mine says 5.66038 times 10 to the second. Okay? Which to 3 sig figs we could write as 566. And if you want, make sure you know how to switch back and forth in case you need to. All right, so that one I think is probably just as easy or maybe easier just to set up as a unit conversion, using your density, flipping it to convert. Now I'm going to show you, we could go to the density equation, rearrange it, and then just plug in. Yes?
So when we do quizzes, would you rather have a better answer in the decimal point or in centimeters?
It really doesn't matter, but certainly if it's quite a large number or quite a small number, you will probably want to use scientific notation. So I would certainly say, anything probably 10 to the fourth, 10 to the fifth or greater, you would certainly want to use scientific notation, or going the other way, 10 to the negative fourth, 10 to the negative fifth or smaller, use scientific notation. Otherwise, you're going to be writing out, why write out 1,000,000 if you can write 1 times 10 to the sixth, kind of thing. Okay. All right, so let's look at it this way. We have about 8 minutes left today. So we could use our density equation. We want to solve for volume, so we could rearrange this equation. Okay, I think this is actually harder. We're in effect, we are multiplying both sides by volume, and then we are dividing both sides by density. Okay, so volume cancels, density cancels. Okay, so we got to do the work to rearrange, not that hard. So we end up with volume is mass divided by the density. Now we can plug in our numbers. And of course, we get the same answer. Okay? Now, make sure you notice your units here. So if you set something up like that, the grams do cancel out. We have grams in the numerator, grams in the denominator, and what we're left with I can write. We're left with 1 divided by 1 over milliliters. Does that equal milliliters? Maybe? Yes, okay. So that looks a little odd, but if we actually multiply this by milliliters over milliliters, okay, milliliters divided by milliliters is just 1, so I haven't changed anything. This milliliter is above this one, so that will cancel, and we are indeed left with milliliters. Okay? So I think that's more work to rearrange the density equation and plug in. I would much rather just do a quick unit conversion with my density. Yes?
With that, couldn't you just flip and multiply, like the milliliters over 1? Like, couldn't you just flip it to be milliliters over 5?
Yeah, well, yeah, so you could,
Easier?
let's see, if we invert, milliliters over 1 here.
With the one where you had 1
Yeah.
Can you just flip that and multiply it and use this one as multiplying it by milliliters and milliliters?
I don't know. I've always just multiplied it by 1. So, yeah, sure. I don't know. I've never done it that way. Okay. All right. Let's see. What do we have? We have 5 minutes left. So let's see if we need to do. Oops. Let me just check because there's more. Oh, I didn't want to do that. Okay. There's one more density example I want to see. I don't want to do, we don't need to do too many of these. All right, let's just do the third one and then we'll go from there. All right, you may have seen the answer, but see what you can do with this one, and then we'll talk a little bit more with density, about density. That almost gets us to the end of chapter 2. Tomorrow we'll talk a little bit about temperature scales, and that'll pretty much wrap up chapter 2 for us, so we will be getting into chapter 3 tomorrow. Okay, so set this one up. You could set this up as a conversion. You could use your density equation. You choose how you want to solve this one. See what you can do here. And don't forget, oops, that's not what I want to do. Go back. Make sure you have those conversions locked away somewhere. You will need those. And we'll wrap up with this calculation today. If you have any questions, let me know.
For something like this, with the sig figs being at 3 and your answer being in the thousands, would you write it in?
Yeah, so in that case, I would probably convert that to scientific notation.
Okay, and then just do 3.
Right. How are we doing on this one? This one's a little harder. All right, for sake of time, I know some of you are still working. I'm going to go ahead and start because we only have 1 minute left, so I want to get this calculation done before we call it a day. So I'm going to start with the 1.32 liters. Okay, what is the mass of a block of aluminum with a volume of 1.32 liters? I want to end up with mass. So I'm going to say grams since I notice my density has grams in it. Okay. Now, the other thing I'm going to do very quickly is just in my mind, I'm going to write this as 2.70 grams per 1 milliliter. Can I do that? Yeah, because a centimeter cubed and a milliliter are the same. Okay. So then in my mind, that's my conversion factor. So I need to get my liters to milliliters. Okay, so my first thought is I need to get to milliliters. And then once I get to milliliters, I can use my density to get to grams. So I've just written units in there to kind of guide my path. So let's write some numbers in there. How many milliliters in a liter? 1,000. Okay. Liters in the numerator, liters in the denominator, that's just one. Next step. Just, we already have it. We have the density. We want that just straight up, 2.7 grams per 1 milliliter. Milliliters in the numerator, milliliters in the denominator, that's just one, that goes away. So, 1.32 times 1,000 times 2.7. So I apologize, every single one of these problems was 3 sig figs. Again, the middle one's exact, these other two are 3, so we carry 3 in our answer. Okay. All right, we are over time. If you have any questions, come on down. We will, again, there's really, we might talk a little bit more about density tomorrow, a little bit about the temperature scales we'll use, and that'll wrap chapter 2 for us. I don't know where the attendance sheet ended up. Did everybody get the attendance sheet today?